So homework is for practicing the processes.
Can you still go back and maybe do more math points?
The ones from those weeks that are still open for you, those assignments are. Bonus points, nope, I'm not taking bonus points anymore. So you can go back and work on any of those assignments that are open and get more math from the last 3 weeks. Those are what's still open. Okay, so example 1 here. How am I going to tell from a table whether or not it's linear, quadratic, or exponential? What did we do on the front side? Anybody who has their notes still?
Didn't we tell if it was like times or
Exactly, yep. So what changes from 7 to 4?
3.
Minus 3. From 4 to 1?
-3.
Okay, does that same pattern go all the way down? Okay, so if it's a subtracting or adding pattern, is it linear, quadratic, or exponential? Linear. Okay, so you can just put a big L in that box. Example 2. What type of equation is that? It is exponential. The x is your variable, so that, the x is your exponent. Okay, the variable is in your exponent spot, so that makes it exponential. What about the third one? Quadratic. Why? Because it's U-shaped, right? It's that parabola. It's U-shaped, and the Q always needs a U. Okay, this fourth one, exponential. It's a curve. It's not a straight line. It's not a U. It doesn't come back up on the other side. It flattens out on that side. Okay. What about the fifth example? Quadratic. How can you tell?
Well, I have it on my journal.
Okay. So what's different about the Y's over here? What's the pattern?
It's like -3, then it's -1. It's like
It's not multiplying the same every time, right? Okay, but if you notice the pattern, they go down and then they go up, right? Which means that it would start out at 7 and it would come down and then it would take a U-turn and it would go up, right? So it would make a U-shaped graph. So that's what makes it quadratic. What about the last one? Linear. These notes are from Friday. You should have them already. One from the Friday before the snow break. I didn't have a handout with highlighted stuff for you, so you were here. I think you weren't still in ISS.
Cutter, wake up, dude. I'm awake.
So it looks like this. One. If you don't have it, this is my last one. Okay, look at that example number 7. Yep, that's it. The population in Smallville was 234,710 in 2000. If the population is growing at a rate of 9% per year and can be modeled by the function f of x equals 234,710 times 1.09 to the x power, where x represents years since 2000, find the population of Smallville in 2010. Okay, we're already given the equation. Where did this 2,000 or 234,710 come from?
The population.
Yeah, this starting population up here. Okay, that's the starting amount. Okay. So that's the starting amount that we started with. Where did this 1.09 come from?
The 9% that was going every year.
The 9%. It's growing 9% every year. Well, if we write 9% as a decimal, it's just 0.09, right? So where did that 1 come from?
From the
If I multiplied 234,710 times 0.09, would it go up? Would it grow or would it go down?
Grow. It's positive.
Put it on your calculator. If you didn't grab a calculator, you're going to need one for everything that we're doing today. And so y'all need to start grabbing a calculator as you come in without being told to.
Oh, stretch. I'll stretch the hamstring out. Hey, Cutter, you need a calculator.
Anybody want one?
God bless everybody. America. Make America. I hear Make America great again. Yeah, everybody. America is great. So Trump did it. He made America great again. Black lives matter. All lives don't matter until black lives matter.
So when you times 234,710 times 0.09, does it get bigger or smaller? Mm-hmm. 0.09.
It gets smaller.
It gets smaller.
It goes down to
Right?
15.
Okay, so if it gets smaller with 0.09, is it actually growing? No. So this 1 right there in front represents the 100% that we start with. Right? You always, when you're talking about percent, have to start with the 100%. If it's growing, you add to that 100%. So 100% plus 9% gives me 109%. Okay, and then if I put it in a decimal form, it's 1.09. So in your calculator now, calculate this equation. What am I going to substitute in for the x? Because it wants to know in year 2010 what the population is going to be. What am I going to substitute in for x?
10.
Why 10?
Because it went up 10 years.
It went up 10 years because it's only talking about the years since 2000, right? So you're not going to use all of 2010. You're just going to use 10. How many years it's been since 2000. So in your calculator, type that in, and when you get an answer, tell me what that answer is.
Wait, so I'm doing 100?
You're doing this formula that they already gave you, but you're substituting a 10 in for the x. Everybody should be doing this on their calculator. Come on, guys. I'm tired of y'all saying y'all don't know how to do stuff because you don't practice it when I'm asking you to practice it in class. If you've got a number for me, then give me a number.
Okay, if I put it there right, it's like 5, 5, 5, 6, 4.
Mm-hmm.
I didn't have it, but I didn't.
Okay. Was there any decimal point after that? I mean, was it point, any numbers, or just a decimal point? Okay. So because we're talking about population, we don't deal with decimal point numbers of people. So if you were to get a decimal point number, okay, then round it up accordingly or round it down. So if it were 0.5 and bigger, then you would round it up. If it were 0.4 something, then you would leave it as 4. Okay? So population in 2010 would be, okay, 555,644. So now let's look at this next one. Okay. The Johnsons have $25,000 saved.
Yeah, I got it.
They have $25,000 saved for their son's college fund. They invest the money in an account that earns 5.5% interest, compounded yearly. Okay. Here's your equation. If this is your equation, I've already wrote it out for you. The only thing you need to figure out is what to substitute in for the x. So what am I going to substitute in for the x, reading the rest of that problem there? 8. So in your calculator, type this in with an 8 for your exponent.
The burritos weren't fat, my guy. What happened?
3, 8.
3, 6, 7.2.
Okay, and because we're talking about dollar amounts, we are going to have 2 decimal places. Cut her head up.
You gotta go to bed earlier.
So if he's earning interest on his money, would you expect this number to be bigger than the starting amount?
No. Well, yes.
Yes,
Well,
if you're
it's
earning interest, right?
If it's interesting,
Right?
yeah, it's
You'd
going up.
expect it to go up. So is 38,000 bigger than 25,000?
Yeah.
Yeah. So
By 18 million.
okay, on the next page, we already had this blank filled in from the very front page, but here it is again. So an exponential function is a function whose independent variable is in the exponent. That just means that your variable is your exponent. This number out front that is not raised to the power is your initial amount, your starting amount. Another word would be beginning amount. Right? Any of those words, any of those phrases would indicate that you're talking about that number out front. Your base, this other number here, that's raised to the power, that indicates whether or not it's growing or decaying. So if it's growing, would you expect it to go up or down? Would you expect the graph to go up or down?
Up.
Up. You would expect it to go up, right? If it were decaying, would you expect it to go up or down?
Down.
Down. Right? So if it's growing, that number raised to the power is going to be greater than 1. Look at those 2 word problems that we just did. The number that was raised to a power, was it greater than 1?
Yes.
Yes. What happened when we used 0.09 instead? Did it grow or did it decay?
Wait, it went up.
It decayed.
It decayed when we only used the 0.09, right?
Yeah,
It went down, right? So if it is a decaying function, the number raised to a power is going to be between 0 and 1. So that could mean that it would be a fraction, a proper fraction, where that the top number is smaller than the bottom number. Okay, or it could be a decimal that's 0 point something. Okay. The negative signs don't really apply to whether it's growing or decaying. The negative sign just says it reflects over the axis. Okay, so, and it will usually be paired with this number out front here, not typically with your base. There is an important thing to remember here, okay, that when the rate is given as a percentage, okay, it has to be changed to a decimal, just like we did in that the problems, those word problems that we had before. This work was already done for you. If it's growing, you're going to add it to 1 because you have to add it to that 100%, right? So you're adding it to the 100%. Over here, if it's decaying, then you have to subtract it from 100%. Okay? So that's why it's 1 minus, because that 1 represents the 100% that you start with. So use that information and write your equation for these two problems. Okay? They're going to start with y equals, both of them. Okay? Think about what we just talked about up there. Use this information, read it, use this information to come up with your equation. You're not solving anything, you're just writing the equation.
What, so I just feel like
Oh yeah, just a gangster.
Wait, what is B represent? Oh.
I'm getting a paper. Pressure didn't hold. My name's Petsy.
You didn't even write up here, but
Is breakfast ready?
Is it supposed to be like this? I don't know.
right here, this, when it's a percentage, you gotta use this.
Get it, girl. Period.
Plus.
Ooh.
So it's supposed to be like in front of it. So it's supposed to be like this.
Jonathan, she was running off your Wi-Fi all week.
Oh.
Okay. So some of you were working on it and some of you were not. Okay, when I ask you to work on it, I need you to work on it. Okay, so now that we've done this one together, we'll talk about it and hopefully you'll be able to do the next ones after we talk about this one a little bit. Okay, the initial amount should have not been hard to figure out, right? Where it goes, right here at the front. Okay, the initial amount is that A that we start with. Okay, the rate of growth though, okay, this one says it's growing, which means I need to use this up here. I need to use 1 plus whatever my rate is as a decimal. So 1.2. So 1 plus 0.20. Or if you want to think about it in percents, 100% plus 20% is 120%. And then if I change it to my decimal, it's 1.2. Okay, so you can, there's nothing wrong with putting the 1 like that in the parentheses to the x power. That's fine. That shows your work. That's fine. Okay, this is the most simplified version here. Okay, over here, because it was decaying, since it was decaying, it was a subtraction. So same thing, you use this up here, 1 minus the rate that it's decaying. Okay, so 100% minus 6% gives me 94%. Okay, and then if I change that to a decimal, it's 0.94. When you change it to a decimal, you don't need the percent anymore, guys. Okay, so you either have the decimal or you have the percent. You can't have both because if you, and this is a common mistake I see, but if you have 0.94% and you change that to a decimal, you have to move the decimal point 2 more places over to get rid of that percent sign now. Okay, so it's either one or the other. Don't have both. Once you change it to your decimal, don't keep the percent sign on it. Okay, so, and if you're not sure how to write a percent as a decimal, think about a percentage, okay, as cents. Okay, and cents are pennies. So if I had 100 pennies, I have $1, right? Okay, if I have 20 pennies, I have 20 cents. Okay, 0.2. So that's how you can think of your percentages, okay, as decimal points. Think of all your percentages as how many pennies you would have and how would you write the number of pennies that you have. Okay. So next problem, okay, these are both word problems, but they have the same information. Look for your beginning amount and look for how it's changing. What's the rate? Is it growing? Is it decaying? Okay. And write your equation.
Good work,
Okay.
Mom. Good work.
Okay, so this one hopefully was a little bit easier since we walked through those other ones, right? The very first one, number 3, was a decaying problem, which means you had to subtract 100% minus 50% leaves you 50%, or 1 minus 0.5 is 0.5. So in number 4, it was growing, so you had to add to that 100%. So 100 plus 8 is 108%. Then if you change it to a decimal, it's 1.08. And the rabbits began, or their initial population was 22, so that's your starting amount. Over here, the isotope begins with, so that's your starting amount. These next two problems give you the equation, but you need to pick it apart. Okay, so there's your equation. Answer, what's the initial amount? Is it growing or decaying? And what is the rate? Remember that the rate is going to be as a percentage.
Pumpkin.
So on this example here that y'all just worked out, guys, how did you tell? So should I?
That's the second time.
I know it is the second time. I'm totally drawing a blank.
What?
LaParis.
Yeah,
Sorry.
bro.
Okay. I was drawing a blank. LaParis, I'm so sorry. Okay. So, how did you determine that it was growing?
Because of the horn.
Wow, are you the
LaParis is answering it. So,
I heard it because it says it's greater than one.
So if this number raised to the power is greater than 1, right? Right? And where did you find that out if you forgot? Up here, right? In the top of our notes, growth is greater than 1 and decay is what? Lower than 1, right? Between 0 and 1. Right? So up here in this one, we've got 0.4. So is that greater than 1?
No.
No, it's not, right? It's between 0 and 1. So that's how we know that one's decay. So this right here, so number 5 was easier to see the growth rate. Gentlemen, come on. Number 5 was easier to see the growth rate, right? Why is this 60 and not 40%?
Because you minus 1.
You had to minus something from 1 to get the 0.4. That's why it's the 60 or the 0.6. No, it's decaying because it's 0.04 or 0.4, right? But it's 1 minus something gives me the 0.4, and that's the 60, right? So what you see here is the end product after you take away the decaying percent.
Wait, so Miss, I have a question. So,
Mhm.
so you did 1 minus 7, right?
No, well, I did 1 plus something gives me 1.7. But yes, you can do 1.7 minus 1, right? And that gives you the 0.7.
It's hard to see because I got those up there at the top, but I was trying to figure out how you got to 60.
Okay, so and the 60 because it is 0.4 minus 1, right? If we're taking the same part and we're subtracting 1 from it, we will get a negative 0.6. But we don't use the negative sign because the decaying tells us that it's negative. Okay, so that's where the 60 came from. That's why it's not the 0.4, it's not the 40, because that's our end product after we subtract whatever the decaying rate is. Right? Because up here, we took 100 and we subtracted 50 and we got 50. Right? So that one's maybe not a good example. But up here, on this one, notice that it's 0.94 in my thing here, but my decaying percent was only 6%.
I was just trying to figure out how you got the 90. I know how you got the 94 on that part, but I was just trying to figure out how you got the 60.
We still have a couple more questions, guys, to go over. I know the bell's about to ring, but we need to talk about, not these bottom ones, but we do need to talk about the next page really briefly, which are pretty self-explanatory questions. Okay, So looking at this graph really quick, is this going to be an increasing or decreasing graph? Decreasing. See, self-explanatory. Exponential, because that's the kind we've been talking about, right? Okay. From year 0 to year 3, how does it change? Well, it starts out at 11.
And it goes down.
And it goes down to what?
3? No, it goes down to
To 6. So 11 to 6, how far down is that?
5.
5. And it's 5,000. Guys, it's $5,000 down because, so it's down by $5,000 because right here in the units it says in thousands of dollars. Okay? And how does this number compare to the initial value? Well, it decreased, right? Okay, so these problems are pretty self-explanatory if you're reading the graph. Okay, initial amount is always the one at 0. So you should be able to finish all your Get More Math points now. There are 6 for today on there.
I already started it, but I didn't know that it was.
Today's.
I got
Yeah, some of them, when I started it first period, I saw some people were working on them, and I tried to send notes saying to work on them. Go back and do a different assignment, not today's. But.